Okay, I want to go through another trig equation, slightly more complicated than what we've done before. This one we're going to try and solve cos of theta plus 2 equals 2 sine squared theta. Okay, as you look at this, you need to start picking out structures that you recognise. And hopefully you can see the problem. We have sine theta here, or sine squared theta, cos theta there. We have different trig ratios. That's an issue. Can we do anything to make sure that we have the same trig ratio? Well, you need to think of the identities that you know. You should know that sine squared theta plus cos squared theta equals 1. And if we rewrite that so that sine squared theta equals 1 minus cos squared theta, then we can make a substitution. Cos theta plus 2 equals 2 lots of 1 minus cos squared theta. And so although we've got some work to do, we now just have cos theta. And hopefully you can see that it's a quadratic. So let's see what we've got. Cos theta plus 2 equals, expand the brackets, 2 minus 2 cos squared theta. I don't like that negative 2 cos squared theta. I think I'll add it to both sides. We've got 2 cos squared theta plus cos theta. Take 2 off each side, and I've got equals 0. Should also maybe just say, again, let's suppose that we're to solve this between 0 and 360 degrees. Right, now it's a quadratic. It's the sort of quadratic that's very easy to solve, but people don't do them very often and forget the basic strategy. Yes, we factorise, but because we haven't got a number term on the end, what we can do is say cos theta bracket 2 cos theta plus 1 equals 0. And so cos of theta equals 0. And separately, 2 cos theta plus 1 equals 0. Now, theta equals inverse cos of 0. Theta equals, the calculator gives us 90. And here, cos theta, subtract 1 off each side and divide through by 2 makes negative 1/2. So inverse cos of negative 1/2 gives me 120 degrees. But as we saw in our last example, we need to draw 2 graphs to judge whether there are other solutions between 0 and 360. So let's see what we can do. Let's take it back to there. So we need to sketch 2 graphs. Both of them are going to be the cos curve. Let me get it right. Very important to sketch the correct curve. There we are. The cos curve looks like that. Between 1 and minus 1 on the y-axis. Between 0 and 360 on the x-axis. Now, cos of theta equals 0. There's 0 just there. There are 2 solutions. This is the 90-degree solution that the calculator has found. This one here, by symmetry, theta must equal 270 degrees. Here, cos of theta equals negative a half. Negative a half is about there. And so the solutions I'm looking for are in these two places here. That's 180 degrees in the middle. So there's my 120 degree calculator solution. And there's a 60 degree gap up to the 180 middle, and another 60 further on from 180 makes 240. So I reckon 240 degrees. Now, quite a good habit to get into is to pick out the solution which is most likely to have gone wrong. That is, you've put the most work into it. I would judge that it's the 240. And you can take that 240 back to any stage in the working that you like. You can even take it back to the first line. If you substitute 240 into the theta on the very first line, do it once for the left-hand side, once for the right-hand side, you should get the same decimal coming out. You can try that yourself. So, final answer, we have theta equals 90 degrees, 120 degrees, 240 degrees, and 270 degrees.